Welcome to Gen.Struct.2 and Lat.Forces, Lesson 3 quiz, question number 8. And it says that we should select the correct statement about double ankle compression members in a steel truss. It gives us A, B, C, and D as possible answers. Alright, so, excuse me, let's look about, select the correct statement about double ankle compression members in a steel truss. We have to remember double angles look like so, and they'll have some sort of spacing in the middle. And I'll say 3/8. It doesn't have to be 3/8, and you can actually have, depending on how long these legs are, you could potentially, so you'll, first of all, you have a RX and RY, so axis, you can say this is X axis and your Y axis comes through there. So potentially you could actually have a larger moment of inertia and radius of gyration about the Y axis. And typically, if you look at it just a typical I beam, you will have your X axis and your Y axis, and I'm not even sure, I can't say all the time, but 99% of the time, this YY axis, meaning the bending and everything about this axis, so if you try to bend it like that, that is usually your weak axis, and the X axis will usually be your strong. 99% of the time. I may even go as far as saying 100% of the time, but I won't, because that may not be true. In some situation, you might have you could have something that looks like this, like a giant TIE fighter on its side. Anyways, and this would actually have a stronger, if you look at it, the YY would be stronger because it has more away from the, which, you know, in this case, it may even, the XX axis may still have a bigger I and S and R. This is moment of inertia, section modulus, and radius of gyration. And they're all based on your section properties and what your shape looks like. So anyways, and I won't go over this. This is sect mod. Okay, those are my quick, what they are. And so that's what for a typical I. Normally 99 to almost every single time, your X axis will be stronger than your Y axis. And that will, actually that will, I'll say, well, that will not always be the case with your double angles. And if you go into your steel manual, hopefully you have one, and go to the front, because that's where they keep the section properties. It should say PROP for section properties, and just start flipping through until you should see W shapes first, and then you'll see channels and eyes or angles. You'll see all types of things. The double angles should be around, if you have the same, I have a allowable stress design, ASD 9th edition. It's green, and it starts, double angles look like they start, and you can have two equal legs or unequal legs, and it looks like they start on 1-75. And I think I ran into an example earlier where the y-axis was actually the strong axis when I looked at it. So, as I said before, it's not always the case where you're going to have your x-axis be the strong axis, especially with these double angles. So look at the double angle, and the y-axis may actually be your strong axis. And that is especially important when you're looking at this radius of gyration. In trusses, which we're doing a section on trusses. I believe that's what lessons 4 is pretty much about, all trusses all the time. And you're going to have axial forces only. And hopefully you remember that axial includes two things. It's either compression or it's going to be tension. So push or pull. And in compression is going to control, I won't say all the time, but the majority of the time, not even the majority, almost all the time. There might be some different situation where you you can justify where tension will control, but it will typically not control. It's a simple P over A. So P over A for tension. And compression is also P over A, but you need to worry about, and that's why you can always say compression will control because it's going to be P over A, but you have to remember about buckling for compression. Tension does not worry about buckling, and therefore that's why compression is going to control almost every single time, and it might be every single time depending on who you talk to. So we have buckling, and remember buckling has to do with KL over R. This K has to do with the way it's your end conditions, I'll call it. When I say end conditions, I mean fixed, free, pin, etc. That type of end condition. So you need to look at it in the direction which you're going. So let's say you have, well, in trusses they're going to be pin-pin. So you're going to have to look at pin-to-pin, which is like this, which is a K of 1.0. So pin-pin has a K of 1.0. And once again, I wish I had this tab, and I may have a tab. Let me look around real quick. And you can actually find out these K values once again, and I've went over this in past videos. It's actually on page 5-135 in the steel manual, and you can see in table C-C 2.1, and you can see that we have pin-pin, which is condition D, is a 1.0 theoretical value and recommended design value of 1.0 as well. So in trusses, you will 99% of the time, I would always use 0.9 unless I had a certain circumstance that said, hey, I cannot in my right mind call this a pin-pin connection, but that's the whole point of trusses. You're supposed to put them and design them so they have a pin-pin, or assumed pin-pin. So your K is going to equal 1, your L is your unbraced length, and your R is your R for whatever direction. You can get that out of your steel manual as well in the section properties in front. So I think I beat that like a dead horse. So we're going to go ahead and go on to the answers here. Let's look at, actually we'll go over the question one more time. It says select the correct statement about double angle compression members in a steel truss. And we know that compression, you need to look at your R. Alright, so it says the design is based on Rx. And that's not necessarily. It could be Ry as well. Depends which one is your weak axis. And especially with these double angles, it cannot be assumed that your x-axis is going to be your strong axis. So design is based on RYY. That's incorrect. For the same reason, design is based on RZZ. Incorrect. The design may be based on either Rx or Ry. And there you go. D is the correct answer for question number 8. I will see you on the next video.